Okay guys, so this is going to be your molarity and parts per million notes. So you'll need your packet, open it up to page 16. You also want your reference table. We're really going to want table T for this lesson. And you definitely want to have a calculator. We need to try some problems, make sure we're getting the right answers. So again, we're going to page 16. We're going to start with our molarity. So what is molarity? So do you remember mole conversions? Because that's what it's based off of, moles. So I see I have table T here. So flip your reference table to table T at this point. And when you go there, I want you to find the concentration, which you'll see is listed right below percent composition and right above the combined gas law. So I'm actually going to learn two things today. I'm going to use this molarity equation, which tells me I have my moles of solute per liter of solution. That's going to be very important. So it is moles over liters. So a lot of times I write it like this. You show molarity as a big M. Remember, mole is MOL, liters. So molarity is moles per liter. And I'm also going to learn today about parts per million. Parts per million is when I take the mass of the solute over the mass of solution. I times it by, you got it, 1 million. That's for very, very small things. So we'll start with molarity first. So let's start by saying molarity is really just a concentration. And when I think about concentration, I'm just saying how much. So molarity describes how much. Molarity, like I showed you before, is shown with a capital M. So that is its symbol for molarity. But you must capitalize it. If you do not capitalize it, that will not be correct. So molarity is a capital M. An example of this might be if you see this, 5M. How I say that M is molar. So this would be saying that my concentration is 5 molar when I say that. So molar has to do with molarity. And I have already looked at reference table T, and we want to grab that equation that we have from reference table T. So we see that molarity equals our moles of solute all over liters of our solution. I'm going to kind of highlight that this is important to me. I could rewrite it just like I did over there. Molarity capital M is moles over liters. And actually, the units, you got it. Okay? Our units, it doesn't look like units, it says units. Oh, I erased it. I know, you guys are used to this in class too. So units equals moles per liter, or I just write it as a capital M. So very easy. That is your units. The important thing to remember is that it must be in liters. It has to be in liters. This is super important. So if they give it to you in milliliters, you want to be careful. Remember that 1 liter equals 1,000 milliliters. You may need to convert. It must be in liters. There's already a star. I'm going to add another one. I also may need, because in this equation you could see that there are moles in my equation. So I may need to convert from grams to moles first to get me there. So that will be important to remember that. So let's go back to our table T. Flip back there now. I want to look for my mole calculations. See, I'll go back. Here's my mole calculations. Remember, moles is your given mass. all over your gram formula mass. That will be very important. So let's write that here. Moles is your given mass. I'm just going to write mass over your gram formula mass. Remember, gram formula mass is when I add up all of the masses of every element and I get that combined mass. So let's look at some examples. Just do these right with me in your notes. So first example says, what is the molarity? So I'm going to circle molarity. I'm going to find that. So I'll list over here what I find. Molarity is question mark of 2 moles NaCl in 2.5 liters of solution. Well, I have moles, so my moles equals 2.0. And I have liters. My liters equals 2.5. This is a very straightforward question that we're doing. I simply want to plug in, say, all right, molarity is moles over liters. So I'll plug in, I had 2.0 moles over 2.5 liters. If I plug that into my calculator, which you should, make sure you get this answer, I'm going to get 0.8. My unit will be a capital M. If I say this out loud, I would say 0.8 molar. So my molarity is 0.8. Now I go to the next question, and it says, okay, what is the molarity? So molarity is question mark, I'm finding that, of 3 grams of NaOH in 1,000 milliliters of solution. This is actually really tricky because first, let's start here. My milliliters, I can't leave it like that. I have to have it in liters. We said that 1,000 milliliters was 1 liter. So instead, I need to write that as 1 liter. So my liters equals 1, right? 1, here I'll make it look more like a 1, 1 liter. Now I need my moles. But I don't have moles. I have grams, okay? So I have a mass. But if I look back up at my equation, molarity, and I'll write it right here, molarity is moles over liters. I have mass. But if I go back up and I use my mole equation, I'll do it over here. Moles equals your given mass over your gram formula mass. I have a mass. My mass is 3.0 grams. I can also figure out my gram formula mass. Remember, I have to look up each element. Sodium has a mass of 23. Oxygen has a mass of 16. H has a mass of 1. That equals 40. Is that right? Yep, 40 grams per mole. So I put 3 over 40. That is going to get me my answer in moles. So my moles equals, try this in your calculator, you should get 0.075 moles. So now I'm going to take this, and now I have that to put over here, 0.075 moles. I'm now finally able to go back to this equation. So now I plug in, I say, okay, I have 0.075 moles. I had 1 liter. That gives me 0.075 molar as my molarity. 0.075. This was tricky. I needed to go from grams to moles first. We should write that. Grams to moles first. Okay, now our last problem. What is the mass? Ooh, I'm finding mass. So I actually might want to use a different equation. Let's see. Of BaCl2, that might be important, contained in 1 liter of a 2 molar solution. All right, let's see what I got. I know my liters. I know my volume. That is 1. So 1 liter. And I know my molarity is 2.0. Well, I want mass. The only way to get to mass is to first, I'm going to use my molarity equation. Molarity is moles over liters. Let's solve for moles, because moles is going to help me get back to mass. So I know my molarity. Let's plug in. Molarity was 2. Moles is x. My liters was 1. That leaves me with x equals 2 moles. All right, so now I have 2 moles. Now what I can do is I come up to step 2. I know my mole equation. Moles equals your given mass over your gram formula mass. Well, that's important because this is what I want, my mass. So I'll say, okay, I know my moles was 2. I know my mass. No, I don't. It's x. And I need my gram formula mass. So let's go right here and say, okay, BaCl2, let's get the gram formula mass. Ba has a mass of 137. Cl has a mass of 35.5, but there's 2 of them. That gives me a gram formula mass of 208. 208. And technically my unit is grams per mole. That's my GFM. So now I go back over here. 208 is my GFM. I'm going to cross multiply to get that x. X is going to equal 416 grams. 416 grams. So remember, super important that I remember, I know I'm a molarity equation now, but I also know my mole equation. That didn't go away. Moles help me get to mass. They also help me get to molarity. Very important that I'm using both of those. So at this point, what I would want you to do is try these problems on your handout to see that you got the right answer. So you should pause now. Okay? Pause now. Good luck. But then come back. Okay, so you're back. We have to do one last thing, and that is do parts per million, which is also known as ppm. We're going to packet page 19 and again to table T, because we saw before that there was an equation on table T right above molarity that gave me my parts per million equation. So this is what your page 19 looks like. Let's just read through and find out what is important here. So when I want to express a concentration in parts per million, this is going to be for small numbers. I do this to make my life easier. So let's read. It says, the amount of solute present in some solutions may be so small that it is necessary to express the ratio of the mass of the solute to the mass of the solution multiplied by 1 million, or 10 to the 6. This is used often when expressing the concentration of contaminants present in drinking water. If you didn't know that, there's many other things in your drinking water. We've talked about that in class. It is not just water. It is all safe for you to drink. But certain things like lead, you don't want to have too much in it. So they will measure it in parts per million. So this is my equation here. This is what you will find right on table T. Mass of the solute over mass of the solution times 1 million. You want to know that the solution, well, that's everything. So that's the solute and the solvent. So your solution is everything. The mass of the solute is just the piece you're dissolving. Things that are going to help you, we should probably label ppm equals this. That the mass of your solute versus the mass of your solution, you're always going to have very little of your solute And you're always going to have more of your solution. So always have more of the solution. So when I go to do some problems, little number on top divided by a bigger number times a million. There are no units except to express ppm at the end of your answer. So you just write ppm. And if you flip to the very next page, we're going to try some problems. So this is page 20. So a couple of problems that I want to try. Let's look at the first one so you can get a feel for these types of questions. It says I have a 500-gram sample of an aqueous potassium chloride solution, and it contains 0.025 grams of solute. What is the concentration of the solution in parts per million ppm? So generally the questions are going to reference parts per million. So I go to my reference table and I say, okay, what's the equation? It is mass of the solute over mass of the solvent. So I'll do my work right here. ppm equals, my mass of solute was right here. So 0.025 divided by my mass of the solution. Well, theirs must be my whole solution because that's the bigger number. So 500. And I have to multiply it by 1 million. So at this point, if you go to plug this in your calculator, you go to 0.025 divided by 500, hit enter, multiply it by a 1 with 6 zeros, and you are going to get 50 parts per million. 50 parts per million. If you go to do a different type of problem, let's skip down to number 4. Number 4, very similar, but I have to set it up a slightly different way. It says how many grams of MgCl2 are contained in 1,000 grams of a 10 ppm solution. So this is my solution. And this how many grams, I want to know how much solute do I have in there. So I'm going to set this up. I can still use this equation. I'll do it right down here. I know parts per million, ppm, equals my moles of my solute. Sorry, not moles. I'm tricking you. Mass. My mass of my solute over mass of my solution times a million. So let's see what I have. I know it was 10 parts per million, so 10 equals my mass of the solute. I don't know, it's X. My mass of the solution, just know that's supposed to be an N. My mass of my solution was 1,000 grams. And I gotta multiply it by a million. So that's the same thing as writing 10 to the 6, by the way. So how am I going to solve this? Well, first get rid of this. Multiply by 10 to the 6, so now I divide by 10 to the 6, or divide by a million. Cancels it. So I go over here and I divide by a million. 10 divided by a million, well, that's going to be small. So I'm going to get 0.00001 equals X over 1,000. At this point, how do I solve it? I cross multiply. So 1,000 times 0.00001 is going to give me 0.01 grams, because I solved for that. So I'm going to look back up and I'm going to say, well, is that my answer? No. They have things in scientific notation. So remember to do scientific notation. You need a number between 1 and 10. So move it over. Not quite. There you go. That equals 1 times 10. So that you moved it over twice. You made it, it was a small number. So it was a minus 2. So 1 times 10 to the minus 2 is our answer. Let's go back up and see if that's a choice. Oh, it is. So I'm going to go ahead and pick this. And at this point, you are done with your notes. Thanks, guys. Have a great night, and I'll see you tomorrow. Thank you very much for watching this.